In the vast spaces between galaxies, astronomers have long suspected that something might be hiding. Ghost galaxies, massive structures made almost entirely of dark matter, with barely enough stars to call them galaxies at all. For decades they remained theoretical, but in February 2026, an international team of astronomers announced they had finally found one. Its name is Candidate Dark Galaxy 2, or CDG-2. It lies 300 million light-years away, in the Perseus cluster. It's one of the most extreme objects ever discovered. Its stars produce only about 6 million times the light of our Sun, but its total mass, dominated by dark matter, is comparable to a small galaxy. In other words, CDG-2 is 99.99% invisible. This is the story of the ghost galaxy, and what it reveals about the dark side of the universe. Why does this ghost galaxy matter so much? Because it represents an extreme, a galaxy that pushed the limits of what we thought possible. Finding such an object was like searching for a shadow in a dark room. CDG-2 is the first confirmed example. Most galaxies are easy to find, but galaxies like CDG-2 are almost impossible to detect directly. The story begins with Dayi Li, a statistician who had a radical idea. Look for the brightest, most durable traces, globular clusters. Even if a galaxy loses its gas, its globular clusters can survive, orbiting the dark matter halo like lanterns in the void. To confirm that this faint glow was real, and not just an artifact, the team needed to bring in the big guns. First, they used Hubble's sharp vision to confirm that these were indeed clusters, not background galaxies or noise. Each one is a dense ball of ancient stars. Next, they turned to ESA's Euclid Space Observatory, designed specifically to study dark matter and dark energy. Its wide-field infrared vision was perfect for detecting the extremely faint diffuse light that confirmed the presence of an underlying galaxy. The final piece came from the Subaru telescope on Mauna Kea. With its 8.2-meter mirror, it provided the deep optical imaging needed. The combination of Hubble's resolution, Euclid's infrared sensitivity, and Subaru's depth left no doubt. CDG-2 was real. In February 2026, the team published their findings. CDG-2 was officially the first galaxy detected solely through its globular cluster population. Let's establish where this ghost resides. CDG-2 is located in the Perseus galaxy cluster, about 300 million light-years from Earth. The Perseus cluster is one of the most massive structures in the nearby universe, containing thousands of individual galaxies. CDG-2 has a total luminosity of roughly 6 million Sun-like stars. Compared to the Milky Way, it's 20,000 times fainter. Remarkably, 16% of that faint light comes from just 4 globular clusters, an incredibly high proportion compared to normal galaxies. But the most astonishing number is the mass. Only about 0.01% of that mass is in the form of visible stars and clusters. The rest, between 99.9% and 99.99%, is dark matter. This makes CDG-2 one of the most dark matter-dominated objects ever discovered. The only visible inhabitants of this ghost galaxy are its 4 globular clusters, survivors while the rest was stripped away. They're just the tip of a massive, invisible iceberg. Without these survivors, we would never have known CDG-2 existed. To understand how CDG-2 formed, we need to go back billions of years. In the early universe, dark matter clumped together under gravity. These halos acted as gravitational wells, pulling in ordinary gas, hydrogen and helium, that would eventually form stars. But CDG-2 had a different fate. At some point in its history, it fell into the massive Perseus cluster. As CDG-2 plowed through the cluster gas, its own gas was stripped away by ram pressure, torn from the galaxy by the force of its motion. This process left the galaxy with almost no fuel to form new stars. Star formation ceased, and the galaxy began to fade. The existing stars continued to age and fade, becoming so faint that they are now undetectable even by Hubble. What remains is a dark matter halo, and the 4 globular clusters that were dense enough to survive the cosmic demolition derby. This evolutionary path explains why CDG2 is so extreme. It's a galaxy stripped to its bare essentials, leaving only an invisible ghost. CDG-2 is more than just a curiosity. It's a critical test for our models of galaxy formation. For decades, simulations predicted that dark matter halos should exist without galaxies. They just never grew massive enough to form stars. Until now, we had never found one. CDG-2 is the first confirmation that such objects can exist, and it matches what simulations predict. For decades, astronomers have been puzzled by the missing satellites problem. We've only found about 50 of the hundreds predicted. Where are the rest? The answer might be that they're there. They're just dark. Objects like CDG-2 could be the missing satellites. Because the galaxy is so dominated by dark matter, it's an ideal place to study how dark matter behaves. By studying CDG-2 structure, astronomers can test these models and potentially narrow down what dark matter might actually be. CDG-2 may represent an entirely new class of objects, an almost dark galaxy that pushes the concept of galaxy to its limit. Are there galaxies with even fewer stars, with only one globular cluster? This discovery opens up a whole new frontier in astronomy. Not everyone is completely convinced. Some astronomers have reservations about whether this is a true grouping. They point out that the 4 clusters could simply be galaxies that appear close together along our line of sight, a chance alignment. To definitively prove they're part of the same galaxy, the team needs to get spectra of their light, a massive challenge at this distance. Li and his team acknowledge the challenge, but point to the faint, diffuse glow detected by both Hubble and Euclid. This glow suggests a common origin. The chance that 4 unrelated objects would share the same faint halo is vanishingly small. The debate will likely continue until follow-up observations can be made with next-generation observatories. For now, CDG-2 remains a candidate dark galaxy, though one with exceptionally strong evidence. CDG-2 is just the beginning. ESA's Euclid mission will survey billions of galaxies over its lifetime, mapping the dark universe. Its wide-field infrared view is perfect for detecting low-surface brightness objects like CDG-2, revealing their hidden secrets. NASA's Nancy Grace Roman Space Telescope, launching in 2027, will be another game-changer for ghost hunting. With a field of view 100 times larger than Hubble's, Roman could discover hundreds of objects like CDG-2 across the entire sky. The Vera C. Rubin Observatory will soon begin scanning the entire visible sky, building up a 10-year movie of the universe. Its unprecedented depth, combined with machine learning, could uncover entire populations of dark galaxies. Perhaps the most important tool for future ghost hunting isn't a telescope, it's algorithms. Humans can't process petabytes of data alone. As Dayi Li demonstrated, combining advanced statistics with astronomical data is the key to finding these elusive objects in the dark. We've journeyed into the heart of darkness and found a ghost. CDG-2 is a galaxy with almost no stars, dominated by invisible matter. It's a testament to human ingenuity, using globular clusters as cosmic lanterns to illuminate what would otherwise be invisible. And it's a window into the dark universe that makes up most of the cosmos. CDG-2 reminds us that the universe is far darker than we imagined. For every shining galaxy like the Milky Way, there may be dozens, hundreds of dark galaxies, invisible ghosts. We're not seeing most of what's out there. We're seeing the tip of the iceberg. This also means our galaxy is the exception. Our galaxy, bright, starry, full of life, is the exception, not the rule. Most galaxies failed. Most never lit up. We're lucky to live in a place where star formation succeeded. The universe is mostly darkness. We're the light. CDG-2 4 globular clusters in the darkness, held together by the gravity of 99.99% invisible matter. It's a reminder that the universe is fuller, stranger, and more wonderful than we ever imagined. And the ghosts are finally coming to light. Thank you for joining us. If it inspired you, share it. Comment below. What do you think is hiding in the darkness between galaxies?